Okay, Assalamualaikum and hello everyone. So now I'm going to discuss chapter 9 tutorial question number 4. So question number 4 is PSPM 2020 and 2021 question. A photoelectric effect experiment was conducted using a metal of work function 1.5 electron volt. Okay, so this is the work function. And the stopping potential of 2 volt, and this is your stopping potential. Okay, so now the first question asks for threshold wavelength. Okay, how do you find for the threshold wavelength? We can find for the threshold wavelength using the work function formula, which is work function equals to Planck constant times with threshold frequency. But now we do not have our threshold frequency, but we can substitute our threshold frequency with c, speed of light, over threshold wavelength. Okay, so we know speed of light is equals to threshold frequency times threshold wavelength. So when I rearrange the equation, kita akan dapat threshold frequency equals to speed of light bahagi dengan threshold wavelength. So we already know our work function, which is 1.5 electron volt, but remember, must change it to joule. And we know, sorry, 1 electron volt equals to 1.6 times 10 to power of negative 19 joule. So from electron volt to joule, kita kena darab, and from joule to electron volt, kita kena bahagi. So now kita nak convert dia from electron volt to joule. Jadi kita kena darab dia. So 1.5 times 1.6 times 10 to power of negative 19 equals to Planck constant, you can get from your list of constant, times 10 to power of negative 34, the value, and speed of light also you can get from the list of constant, the value, and divided by the threshold wavelength. So when you press the calculator, you will get your threshold wavelength 8.29 times 10 to power of negative 7 meter. Okay, so the next question is to find maximum velocity of the photoelectron. So we are looking for the maximum velocity. So how do we tackle this question is, we know we already have our stopping potential, and kita tahu kalau formula untuk kinetic energy, maximum kinetic energy, dia akan sama juga dengan E darab dengan stopping potential, your electron darab dengan stopping potential. And we know formula untuk kinetic energy is half mv squared. So half darab dengan mass of the electron darab dengan velocity of the electron, sorry, this is supposed to be mass squared, equals to electron darab dengan stopping potential. So we are looking for maximum velocity. So it is half darab dengan mass of electron, you can find from the list of constant, which is 9.11 times 10 to power of negative 31, darab dengan you punya maximum velocity equals to electron, value of electron, so you can find from the list of constant, and times with your stopping potential, which is 2. So when you calculate, you will get your maximum velocity 8.38 times 10 to power of 5 meter per second. Okay, so I will highlight the final answer. Okay, so now let's look for the next question, wavelength of photons. So wavelength of photons, okay, how do we find for the wavelength of photons? So wavelength of photons, kita boleh cari, remember the equation I taught you, energy, quantum energy equals to work function darab juga dengan maximum kinetic energy. And we know we need to find for the wavelength of photons, and we know energy, the formula for energy is equals to Planck constant times with the frequency equals to W naught plus, and we know maximum kinetic energy dia juga sama juga dengan electron darab dengan stopping potential. So dia adalah elektron darab dengan stopping potential. But we do not have the frequency. You tak boleh pakai, you tak ada frekuensi. Jadi nak tak nak, you kena tukar dia kepada formula ni. H equals hc darab Planck constant darab dengan speed of light divided with the wavelength of the photons equals to work function tambah dengan elektron darab dengan stopping potential. Okay, so why I use this equation? Because I know c, speed of light equals to frequency times with the wavelength. So when I rearrange the equation, I will get wavelength equals to speed of light divided frequency equals to speed of light divided by the wavelength. So that's why I substitute my frequency with c over lambda. So now I already know my Planck constant 6.63 times 10 to the power of negative 34, and my speed of light is 3 times 10 to the power of 8. And we are looking for the wavelength of the photon. And then work function is 1.5 electron volt, but remember I told you we need to convert it into joule when we are doing the calculation. Okay, plus with the value for the electron, which is 1.6 times 10 to the power of negative 19, and also the stopping potential is 2. So when you rearrange this equation and put into the calculator, you will get your wavelength 3.55 times 10 to the power of negative 7 meter. Okay, so that's all for question number 4.